Hello and welcome to the Automation Village breakout sessions. These are the second part of our virtual trade show series. The first part is live streamed on YouTube. We did that last week. And now is an opportunity for different presenters in different fields to give longer, more in-depth presentations. My name's Chris Little, and I'm coming to you live from Halifax, Nova Scotia, home of the VT SCADA headquarters. And today, this is going to be the Water Wastewater stream of our 3-streamed breakout session event. So if you want to leave this stream and go see what's happening in the oil and gas stream or the cybersecurity and general automation stream, then all you need to do is hop off now. You can do that just by closing this window and then go back to the email you got from Eventbrite and click on a different stream there. It's very easy. You can bounce back and forth over the next 3 hours. Now let's just take a quick look at what's coming up next. We have in this hour, in the water wastewater stream, we have Maid Labs. They will be talking about using a diagnostic volumetric flow meter to get results. We'll have Quintessential Computing, who will be talking about how their quantum EFM improves your measurement data quality. And finally, in the cybersecurity and general automation, we'll have Dispel talking about replacing your secure remote access system. And now, without any further ado, I would like to introduce Ben Beaudoin. He is the founder and president of Maid Labs Technologies, and today he's going to talk to us about using a diagnostic volumetric flow meter to get results. I had to practice that many, many times. Over to you, Ben.
So when I started in 2002, when I started Maid Labs, one of the goals was to do diagnostics. So we made a few instruments. The first one was the Maid for motor event recorder. And the goal with this one was to be able to record the actual current of all 3 phases for up to 3 pumps 10 times per second. And to be able to try to figure out what was going on with these 1/3 of lift stations. So we made a batch of 100 of these units, the first batch we made, and we called all the municipalities around and can you try this on your lift stations? And 15 units went there. So we called them back, said, you know, it's an electrical recorder. You can put this on everything that you want. So they went on aerators, compressors, generators, conveyors, and another 15 went there. So we called all these big manufacturers around, would you like to try this device? It's an electrical recorder. So the other 70 units went there. Well, total of 224 equipment were monitored by our batch of 100 units over a period of 6 months. 1/3 of them had, 32% to be accurate, had daily intermittent anomalies going on. 1/3, and another 18% has the glitches only once or twice a week. So I arrived at to the conclusion that electrical components get sick before they die. Okay, the thing is, all systems, the way they are programmed, are made to report when something dies, not when something gets sick. The idea, if you want to lower your number of emergencies, is to find them when they're getting sick, okay? And that's one of the elements that we'll be talking about. So to do that, what we did, we created a diagnostic software for lift stations that was working with this first instrument that we have made. And most of the graph and the things that I will be showing during this presentation came from that software. And they all came from lift stations that had SCADA system connected to them that was not reporting alarms. Okay, by the way, it's not because I think that most SCADA systems, if not all of them, could do it. The thing is, the way they are programmed, they just use cut and paste for the last 20 years, and they had never thought about adding features that the software is able to do. So this is something that I want to try to push here. One thing I did not too long ago, I decided to analyze the actual pump capacity and runtime of over 150 lift stations to compare what is the variation of one versus the variation to the other. So when you have two identical pumps within the same lift station, one thing that you will see is that your pumps never have exactly the same capacity, the same flow rate. Also, they never have exactly the same runtime. So I can tell you that for every percentage of flow rate variation, you have twice that percentage of runtime variation. And this is true at 1%, it's true at 5%, and it's true at 20%. So if you can gain 1% of pump capacity, you will reduce the runtime by 2%. This is a major thing. So you can use that as a rule of thumb on how can it be used. You will see right away, right now. So let's see how a standard lift station works. Okay, this is how you can increase the efficiency of your pumps. I will explain how you can do that in a second. First, look at how a standard lift station works. You have the off level, which is usually as low as possible. You have the lead level, which should be above it so that your pump run, let's say something like 2 minutes, 5 minutes, something like this. Then you have the lag level that should be a little bit above the lead level in case the flow coming in is just greater than the capacity of the actual pump running. And then you have a high alarm level, which means that both of those pumps working together is not enough to compensate for the actual flow coming in. Or if the pump didn't start because the PLC would have a problem, then it should override all of this and start all the pumps. Okay, that's another reason why. So this is how it works. When you calculate the actual pump capacity, when you do a drawdown calculation, you do it for an average head, which is usually between the lead level and the off level. That's how you calculate it, and it's for that level that you calculate flow rate. So when you calculate a pump capacity of, let's say, 500 GPM, you know that it is for the head that is right there between the lead and off level, if you have used, of course, these levels to calculate it. If you want to, now that we know how regular lift station works, and by the way, one of the reasons why it works this way is because you want to have as much capacity, volumetric capacity above the lead level to be able to accumulate water in case you have a peak of flow rate coming in, and to be able to accumulate that water before it goes through an overflow pipe if you have one, or go back to the suppliers of that water. So if you want to use a flow-based operating system on your lift station, how will you do that? First, you have to set the lowest safe level. Usually it's the actual off level that you already have in your lift station. What is the highest safe level? When the flow rate is very low? Historically, it has been low at that time of the day. There's no rain in the forecast, and it's not raining right now. There's no reason for one pump not to be able to pump that down very rapidly. Then this is the highest safe level. So you need to enter that. Then you need to specify what is an acceptable minimum run time that you think would be acceptable for your pumps to run. And what is the maximum before you would like to switch to another pump running. And you can also specify what you consider a safe flow rate coming in. So when the flow rate is above that value, you should run the pump low in the well. When the flow rate coming in is higher than that value, is lower than that value, then you can run the pumps high. So how is it done for constant feed pumps? So let's see the first situation when the flow coming in is low, which is most of the time, we have to say. The average head we had before is here. What will happen is that the head will move there. So by doing this, it means the head will get lower, and by having a lower head, the pump capacity will increase. And so it's a matter of starting the pump at the highest safe level and to stop them after the minimum run time that you specified. Again, when the flow rate is low, you should run the pump with the lowest pump capacity at that level first. Then, of course, when the flow rate is high, you should run the other one. So let's see now, when the flow coming in is high, what do you do? First, you start your pump with the highest pump capacity, and you don't wait to get the lead level to start your pump. What you do is that as soon as you know that your pump will be running, let's say 2 minutes, because that's what you would have specified, you start your pump. You don't wait to get the the old lead level and run your pump for 2 hours or 3 hours. You start them as soon as you know that they will be running at least the minimum run time that is normal. What that does is that it will delay when you will start the lag pump by quite a lot, because now you have a way more capacity to compensate for the actual flow coming in that could get above the lead level. And by delaying starting the lag pump, then you will increase the overall efficiency of the entire lift station. So next thing after that is what do you do with variable speed pumps? It's the same thing. Right now, the way they are programmed to work at a low level. The idea is to adjust that level proportionally to the actual flow coming in. That's what's important. So by doing so, you will increase the efficiency of your pump. And of course, a fringe benefit behind this is that the grease buildup that you have around your lift station will, of course, be split between higher and lower. So you might need to clean your station, maybe not as often as before. To be able to do that, how you connect your PLC? Okay, first you have a real-time volumetric flow meter. Of course, we produce one, and this instrument got a few ways to communicate to the PLC. One of them is we have an analog output, which is proportional to the flow coming in. So by connecting this output to the PLC, it is one way is just to program the PLC with two sets of value, running high and running low. And when the flow rate is higher than a value, you run them low. And when the flow rate is lower than that value, you run them high. That is an easy way to do that with only one analog input to it. The other way is to connect to the TCP/IP Modbus of our instrument and get that value. And at the same time, which pump should start and when. So that's another way of doing it. Since we're calculating the pump capacities at every cycle, then we're able to say which pump is the most efficient, the one with the highest capacity. And when the flow rate is low, you run the one that has the lowest flow rate. And when the flow rate is high, you use the other one. So that's another way of doing it. On the Volucalc, we also have a relays. We have up to 4 relays that could represent up to 4 pumps. And when we close relay number 1, that means start pump number 1. When we open it, then stop it. So that could be a way to do that. And a fringe benefit of this is that in lift stations, most of the control equipment has backup. I mean, you have 2 pumps, you have a spare floats, you have a bunch of things that are related to backups, but you don't have a backup PLC. It would be possible to just put a switch to transfer the control to the Volucalc if you would want to, if you would need to repair the PLC, and then after that, get it back. Yes, the Volucalc could be a controller, but we never thought to be wise for the monitor to be the controller, because if the controller failed, I don't see how the monitor would not fail at the same time and report it. So that's the reason why, even if the instrument has everything it needs to be a controller, we never wanted the instrument to be a controller. Now the next thing is, how do you calculate in reality the potential return on investment of such technology? How do you calculate the savings that you could make? And I made a spreadsheet for it. I mean, if you look at that spreadsheet, I have it here, you can download it, and you have explanation on every element of it. So I'll just explain it here, and you can download it from the link that you see down there. Main thing, you need to enter the actual levels of controls that you have in that lift station. So which is the high alarm level. In reality, it's at which level you would think it would be still safe to start your pump. probably right below that high alarm level. What is the actual lag level, the actual lead level, the off level, and if you want to add as a reference a alarm low level, you can also enter that. Next step is to calculate the actual average level for which a pump capacity is calculated during a drawdown. In this case here, we just do the average between the lead level and the off level, and that gave us 3.5 feet. Then we calculate we do a drawdown, okay, and we arrive at 500 GPM. Let's say that's just for the calculation here. Next step after that is, okay, at what level we could run these pumps and what would be the average level of operation. So let's imagine that we could start the pump. When the flow rate is low, we could start the pump almost at the high alarm level, and we would stop them 3 feet lower like it was the case before, which is by coincidence arrive at the lag level. So that's again a 3 feet difference. And the average between 9 and 6, that gave us 7.5. So we have a 4 feet difference in head. That's what it means. So now that we know that we had a 500 GPM, we look on the pump curve. Then we look on what would be the actual GPM we would gain if the head would be 4 feet lower. Let's say that we arrive at 575 GPM. That would give you a gain of 15% in pump capacity by moving by 4 feet. This is based on your own pump curve. You have to use your pump curve to do that. So if you're increasing the pump capacity by 15%, you know that you're decreasing the actual runtime by 30%. And that's how you can really evaluate the kind of benefit you could gain by using this technology. In the spreadsheet I made, I had a few other things to it. What is the cost of the technology? Get a quote, okay? I just entered that value like that, but you need to get a quote because it's clear that for your application, you might have a different number of pumps. You might have different size of pumps. You might want to have a modems to get the data remotely and alarms remotely. I mean, depending on how you want this installation to be installed, it's your choice. But at the end, you enter what is your monthly electrical bill, and it will show you what your return on investment in month and in a year if you want to. So you can use the spreadsheet to see where you should use this kind of technology first. And let's say that you would install this. We have a place in Florida where instruments are installed for that. And just to give you an idea, on in that municipality, what kind of gain we're talking about. We entered these values not in the same spreadsheet that was prior to making that spreadsheet, but we use these pump curves for both pumps and for each of these 7 sites. And what you see on the right hand side here, it's the average level of operation that was changed, okay, based on what was possible. And the average variation was 4 feet 3 inches. And the average pump capacity variation was 17%. In reality, it went from 10% to 23%, but the average was 17%. That means that is the variation in pump capacity. That means 34% in reduced run time. So what was installed to get this? It's quite simple. We just went to install a one current clamp per pump to monitor when the pump starts and stops, and also to know what kind of current was drawn by the pumps, assuming all 3 phase or drawing about the same amount of current. To connect to the actual level sensor that was there, we're using a current isolator like what you see on the left hand side. So we basically piggyback on the actual level that is being there, and that's how the instrument is installed. As you can see, the instrument is very small. You can see it in my hand there with that very small current clamps. By the way, that size of current clamps is good for pumps up to about 50 horsepower because these clamps are good for 75 amps. And But we have an adjustments on the Volucalc so that we can downgrade the or change the actual rating of the current lamp so that they get the highest accuracy at 15 amps. So we have a switch for that, and we have bigger current lamps that can go up to 1,500 amps. So it's a matter of what kind of and what size of pumps that you have. Many municipalities use our instrument as a diagnostic tool that they move around in municipalities because they are so simple to install and move around, and they don't take really a lot of place, so they just leave it on the bottom of the control panel. But just to explain how some of these installations are done. To program the instrument is quite simple. It's just a matter of using the software that comes with it. I mean, you specify the name of the station and the if you have a solar modem or not, and the number of pumps that you have, how you will calculate flow, and if you want to enter pump capacities or not. And then what's the size of the current sensors and the settings that you need for the level sensor and the pressure tap if you want to, if you're pumping into a pressure line and if you want to record it. Also, if you have an overflow pipe, the instrument is an open channel flow meter with about 10 different type of formulas in it so that you can specify at which level the overflow pipe is and the diameter and all these things. And then you can enter also specify that, okay, since it's so rare that two pumps work together, you could say, tell the software that, okay, use a ratio like 75% of the total of these two pumps will be when both of them works together. So it will automatically adjust itself based on the actual drawdown done for each of these pumps. And then you enter the dimension of the well, and you can specify what kind of alarms you would like the instrument to detect automatically. Example of alarms, it's the level drop without any pumps running. You know, it's not normal. A pump didn't alternate even for one cycle. You know, it's not normal. It should be there. Okay, the capacity of the pump has changed since we're doing drawdown every cycle. It's easy for us to do this, something like this. I mean, and you can add, I think, 250 of your own alarms in it. And you can specify the kind of units that you want. And when it's time to calculate flow rate, we always try to specify. We always take the most accurate flow computation that is possible for the actual cycle for which we calculate it. So just to give you an idea, we have quite a bunch of algorithms that we can use for inflow computation, and same thing for outflow calculation. And by the way, calculating flow in order to be able to do a diagnostic with it, it's not as easy as it looks. I mean, this was part of the decor of our conference room for quite a while. And that's how it was possible. That's what you have to do to be able to do real-time flow. So when people tell me, oh, yes, the lowest bidder was able to program this in my SCADA system in half a morning, I would like to hire that person right away, really, honestly. But anyway, so why am I showing a horse with the City of Toronto buggy there? Just because, just to show you how SCADA systems or program has evolved quite a lot. I mean, they are so beautiful and powerful and everything. And like for Excel, you're probably not using 3% or more of the capacity of these systems. I mean, there's a bunch of abnormal behaviors that should be checked by systems. If it's not in the SCADA system, it should be done at the local site and reported to the SCADA system. I think one of the biggest problem is when specifications are done, what is the cheapest way to write specification, cut and paste. So they are today like they were 25 years ago or almost. So, but there should be something related to do diagnostics with these, not only reporting alarms. I mean, SCADA systems should not be there to tell you very rapidly that it's too late. It should be there to find abnormal behavior and report it immediately while it's not an emergency yet. And that's what you want, you really should do. That's what our instrument helps in doing this, okay? So, let's go about the another flow formula that we're using. What abnormal behavior looks like. I will start talking a little bit about diagnostics. First, you need to monitor level and detect abnormal behavior within level. I mean, you can see abnormal behaviors here. I mean, I can show a few of them. These are real. This came from a lift station that had a SCADA system that did not report alarms. The events were just too short to create major problems. But that was really a level sensor. And because of it, at some point, you can see here that the level was getting very high. So all 3 pumps were starting and stopping and starting and stopping. In reality, it looked like, let me try to find it. It looked like this, okay? All 3 pumps were starting at the same time, and they were running for 7 seconds before stopping for 45 seconds, then restarting 6 seconds, stopping 42 seconds, and it was doing this for hours. I mean, and never received any kind of alarm. Okay, because the events were just too short for this to happen. It was switching between the emergency off switch at the bottom of the well, which was telling exactly the opposite of the level sensor that was saying that it's too high, okay, which was starting all 3 pumps. But how can you detect things like this? Another thing also, here you have a level going down without any pumps running. Usually, it's very rare that you have siphon effect. Me, I analyzed thousands of stations in my life. I've seen this twice. So most of the time, it's a defective level sensor. It should be within the system to detect this kind of abnormal behavior, because if it starts doing it when it's not important, it will be catastrophic when it becomes important. And of course, these are the kind of things that we detect automatically in the configuration of our instrument. How in our software we analyze every cycle. I mean, when you have cycles that alternate, it's not because it's alternating that it means it's normal. What you see here is you have pump 3 that started, ran for 2 seconds, then stopped, then they alternate normally, then this time it's pump 2 and this time it's pump 1. And so you need to be able to analyze abnormal behavior, and this is what we have done in our software. I mean, when you look at something, you know, you have a bunch of cycles, and then after that you zoom in and you see there's really odd thing going on. And when you really zoom in, at some point you can see that, oh, all 3 pumps started and they ran for let's see here, 4 hours 25 seconds to 41 seconds. I mean, they ran like 7 seconds, and stop and restart and restart all 3 pumps. That's exactly what I was showing you before. So when we do an evaluation report, it shows that we have a bunch of suspicious events that occur in that lift station during the analysis period. I mean, that's the kind of tools that we have created over time to try to find abnormal behavior. Just on another subject, we're working with the Montreal Polytechnique. It's the engineering branch of the Montreal University. It's quite a large university with 65,000 students. And more, and we're working with their engineering department on trying to find an algorithm that would be able to synchronize the pumps of lift station connected to the same force main. Right now we're working on a genetic algorithm. Yes, genetic, like something that lives, and you have to look at it on Wikipedia. Very interesting technology, and we hope to incorporate this kind of technology within VT SCADA within this year if possible. So anyway, it's something we're working on, just to show you an idea of what is the future of the technology that we're working on. Here is, I went quite, it looks not too bad. So if you want to reach me, of course, here's the ways to reach us. And of course, you can do a print screen of this if you want to and just copy it. That's another way. If you want to have a one-on-one presentation of something that is related to you, don't hesitate to ask us. Most of our reps have demonstrators that they loan for people who want to try our instruments. That's how we sell most of our instruments, by the way. And you can see what kind of benefit you could get out of this. So That's I was trying to be within the time frame, within 1 minute, not too bad. So oh,
Yeah, great
yeah.
job, Ben. You did a much condensed version of this during the virtual trade show, so I'm A, impressed that you got all that in then, and it's great to be able to have a chance to see the whole thing now. I was struck by a couple of things. Yeah, you're right. I mean, a SCADA system shouldn't be like the engine light on your car. It shouldn't be the thing that alerts you when it's too late. So this process is really important. And I also thought to myself, I would really rather have you do this for me than me do it myself. So you clearly have a deep knowledge in this field. Now we have some questions, some pretty straightforward ones. One question came early in the presentation. Can you please explain the lead lag operation?
Okay, lead lag. These are the level, the name that were given to level. The lead is the level at which you start your first pump, not necessarily pump number one. It's the first that would start. When you get to the lag pump, that means it's the second pump that you would start. And trying to get there. Okay, here. And so when you get to the lag level, that means you already have that first pump running. Then you have that second pump that starts. Usually, if the first pump cannot really pump down the water getting inside that well, then wait a minute.
Is somebody calling with another question?
Okay. No, it was my timer telling me
Oh.
I'm at the end of my 40 minutes. So yes, so that's what lead and lag and off are. Basically, it's the level at which you start your pumps.
Great. And the next question from the same person is, now what about when you use a VFD for pumps?
Yes, when you use a VFD, the difference is that you use a level sensor, and so when the level start to go higher a little bit, you increase the speed of your pump, and when the level gets a little bit lower, you decrease the speed of your pump. The idea is to try to maintain that level stable all the time, and you change the speed of your pump or the quantity of pumps and their speed at the same time in order to keep that level low in the well. So if the level continue to increase, you continue to increase the speed of your pumps. At some point, if it's not enough, it will get higher. But the thing is, you try to, the way they are programmed right now, their goal is to run the pumps low in the well in order to be able to accumulate above it in case the flow rate would increase. But when the flow rate is low, and you know it's low, and historically it has been low at the time of the day, then there's no reason to run your pump low. I mean, this is a way to be inefficient. It's like running your car with the brakes on. I mean, there's no reason.
Gotcha. And the last question, actually, if you could move again to your last slide where you showed the, I think they probably already wrote that down now, but can you show the location of the download of the spreadsheet that you mentioned?
Yeah.
So, there it is.
Yeah. You have it right here. It's this is where you can download that spreadsheet. Of course, you
Great.
can ask for, you can go on our website, maidlabs.com, and communicate with me if you want, and I'm there. Of course, I could email it also. You can
That's great. I like that if you've got 17 minutes or just 11 minutes, you've got options.
All the time.
Excellent. Well, I think that's all. If anyone else has any questions, please take a moment to do it. Oh, here's another one right now. Oh, somebody else is sharing that link in the comments. So if anyone wants to copy it out right now, they can do that in the comments section.
Thank you.
In the chat utility. So thanks, Ben.
You're welcome. Bye-bye, Chris.
Coming up in the next hour, we're going to have Mark Romers, who's a really interesting presenter, and he's got a really great case study coming up, a real-world application. And you could also jump over to Mervyn Betts, and he's actually our BT SCADA distributor in Western Canada, and he's having great success out there. And also we have Schweitzer Engineering Laboratories. So but we've got a few minutes, so if you've been sitting and listening and staring at screens, please get up and stretch and walk around. And we'll see you at the top of the hour. There we are. Welcome back. This is hour 2 of the Automation Village breakout sessions, a follow-up to our recurring Automation Village virtual trade show that we live stream on YouTube. Thanks for joining us. Some of you have heard this part before, so bear with me. Actually, I'm going to share my other screen. All sorts of interesting parts and pieces to an online webinar. So just to let you know what's happening in this hour, right now we're going to have Mark Romers here in the Water Wastewater stream, and he's got a great presentation for us. But if you accidentally clicked on the wrong link and you want to be watching Mervyn Betts right now over in the oil and gas stream, all you need to do is cut out of this stream entirely, just hit X in the top corner, go back to the email that you got and click on the oil and gas stream. Same thing with Schweitzer Engineering Laboratories. They've got a great presentation coming up in this hour as well in the cybersecurity and general automation section. So that's what's coming up. So again, here's Mark Romers. Now bear with me for a moment while I connect him up. Hey, Mark, can you hear me?
Yes, I can. We are in Richmond, Virginia. The weather's gorgeous today, and we're very much enjoying the sunshine and all the green countryside, so it's feeling good.
Excellent. I'm glad to hear it. So today you've got a case study for us. This is Mark Romers, by the way. He's the president, you can see, of Industrial Control Systems, otherwise known as Filter Magic. And I don't want to use up too much of your time, but remind people to ask questions in the little chat window as you think of them. And I will let you take it from here. I think I need to stop sharing, which I will do right now.
All right, it's my floor. Chris, thank you, and VT, SCADA, and Trihedral, and the entire team for these wonderful productions that you guys are putting on. It is, it's just a fantastic venue, certainly in these times, but I think anytime. What we're doing now is the new norm. So thank you once again, and I'll get started. This is a case study that Filter Magic prepared as a result of the success of an innovative filter control and backwash optimization system upgrade at the Crosstown Road Water Treatment Plant in Peachtree City, Georgia, where to them, every drop counts. And so they had a lot of goals and objectives for this project, and every technology we have to offer is up and running at this plant. And it is has become a pilgrimage for people traveling around the country to come look at it in Atlanta. Just need 4 hours on the ground, get a tour, get back to the airport, and get a great lunch in between. So I'll get started at this point. This is an old plant. There are many old water plants all over the country. So a lot of folks here that might be looking at this will recognize a lot of what I'm about to show you. But this plant was last upgraded in 1994, and some of the technologies there were even much older. Its average flow is 6.8 MGD. It's 8 filters, and maximum flow before the project was 13 MGD. After the project, it's 23 MGD, but they still run at the same average flow. And this was done because they wanted the capacity to back up their second plant in their water system. So these are the stats: the old clay wheeler under drains, surface sweeps, hydraulic controls. Everything was very outdated and barely functional when we were involved in the project. So pictures again of the kinds of technologies they had. You can see the old consoles in the filter hall. You can see the old equipment, the hydraulics going right up to the console, no wires at all. They were very limited in terms of automation unless they went and stood at the console. And then at that point, every operator used his own opinion on how to best backwash their filters or operate them. At this point, we're continuing to look at this old stuff. And, you know, I've seen it all my life. There's still a lot of it running to this day. Some of it much older, but it's not unusual in the water world to see these technologies. I just like to say that this particular screen is very comical to me, because within their 8 filters, I'm looking at approximately at least 5, maybe 6 of their effluent rate of flow valves. And as you can see, they had a little of everything. Some of it was not even working. This stuff is older than I am in many cases, but the reality is that it ran the industry for the last 50 years, and we should always respect that idea. But we can move forward with new innovative technologies when the opportunity allows. So these are great historical pictures, a couple more. The turbidity there in the left picture is the only thing that they were really monitoring automatically from the filter system into their rudimentary SCADA system that they had at the time. In fact, filters usually get backwash based on time, like 100 hours or 70 hours. And in their case, they didn't have automatic timers, so they would go back to their SCADA system and set a timer manually after performing the backwash. Kind of like your egg timers, just a little bit larger or longer. This screen is very interesting to a lot of people because no one's ever really seen the data contained in the screen. This is what's unprecedented. This is what actually Zero to Waste is focused on. But what you're watching are two different signals that are rarely, if ever, seen on the top of any filter, but it's the missing data to be able to perform a complete understanding of how filter backwashes operate and to use this information to perfect these backwashes. What you're looking at in particular in the orange line is the media level in the filter. And you can see it rise, that butte, that hump there in the red line. That is when the filter has gone into a high wash and it fluidizes the media and it rises. And you can see that the green line, which is the turbidity on top of the filter, and then during the backwash is the backwash turbidity, you can see it goes ballistic and goes right off the screen at the top when they fluidize the bed. That creates a mud boil. But in any event, you can see that it comes down very quickly. Those are 5-minute increments in the vertical lines. But you can see that the high wash continued on for over 10 minutes beyond when the turbidity fell back to a low level. And that is a classic overwash. That is a complete waste of water. And these filters backwash very regularly. This plant did over 1,000 backwashes in a year. And that butte that you're looking at right there is worth 62,000 gallons of wasted water. And there's 1,000 of those, so that's 62 million gallons of water wasted in a given year. This is what we're focused on and where to take filter systems to the next generation, to the next level. But this is a classic example of everything that goes wrong, and it's all over the country to various degrees. We've learned to say, when we meet with folks and we start talking about this, we learn to say, or to not say, that we know you're wasting water. Sometimes that's not a politically correct thing to talk about, but we say you may be, and if you are, we can help you with that. After getting thrown off 2 or 3 plants, we figured out there was a better way of saying the same thing. So this screen has a lot of data on it. That's all bad. And as far as I can tell, 99.9% of the country does not have this data going into their SCADA systems at this time. But we're helping them get it there now, and we're helping them use it for perfect backwashes. This project had a $5 million budget, 8 filters, everything outdated, and the director there had very lofty expectations, and he was very open to using new technologies and not necessarily something that came from the past. So he left the door open for anything to come in that was better and the best. And so they ended up rebuilding these filters to high rate the plant from 3 gallons per minute per square foot to 5 gallons per minute per square foot. That's the translation between 13 MGD and 23 MGD. But that's a 67% increase in production capacity for this plant. They did that without pouring 1 yard of concrete. And they did that by removing the existing underdrains and installing the new low-profile stainless steel underdrains and new media while we were rebuilding the filter control system and the filter pipe gallery with everything else. So all of this led to the unprecedented success of this project. I'll go to the next page here. We also replaced the entire filter control system, and a requirement was that operators no longer had their opinion on how things were done. We wanted this to be consistent. It needed automation to get that done. They wanted an integral filter backwash optimization technology, which we had just rolled out, first in the nation to get it done. It's patented technology. I'm very proud of it, and it will provide precise backwashes, saving tons of water. They wanted all of this, and it took a while to get their operations accustomed to using the technology. They kept wanting to put it back into manual. But over time, they came to completely embrace this technology. It's been running for about 4.5 years, and they Now they continue to work with the tools we've given them, and they continue to perfect their backwashes and filter operations. The data being generated by this is going into their new plant SCADA system as well, and now they're able to do complete historical trending analysis and modeling. More importantly, in a recent decision that we reached to power all of our filter consoles with VT SCADA and industrial PCs, all of that information is now at the consoles, right where it needs to be for operations to use this information to get their job done. So how much did it cost? Well, there was a lot of argument about how this project was going to go down because the director said, I want the best of the best of the best, and I'm willing to do what it takes to get it. And there were predictions that he had blown the budget with those decisions. But as you can see there, he did get what he wanted, and he stayed well within budget. And that's really a moral to the story. You can get what you want and stay within budget. You don't have to go with the past. You can look into the future and apply it. Over time, this project became referred to as the ultimate filtration solution. Our patented technology logos are involved here. Both FilterMagic is a patented technology as well as zero to waste for the backwash optimization. It's important to note that nothing about these patented technologies is proprietary. It's all off-the-shelf, open architecture technologies assembled in a unique manner to do a specific result, protected by the patents for all the research and development it took to do that. Okay, some of the new products that were implemented were the stainless steel underdrains. These were by AWI, leader in the industry in stainless steel. They elected to go not from hydraulic actuation, which is what they had, to electric actuation, which was originally desired, to these revolutionary pneumatic vane actuators manufactured by K12. We'll talk more about them later. That saved them a ton of money and gave them long-term reliability. Also, as a part of FilterMagic, one of our patented aspects is that we utilize an OSI bus network, which means actuator sensor interface. Perfect. That's what we're working with in the filter system, instrumentation, valve actuators. And by using that bus network from our consoles down to all the devices, we eliminated up to 85% of the traditional conduit and wire. Now, they didn't have any conduit and wire, as you saw in the previous pictures. They were going to have to put these conduit and wires in there. And that was going to cost a lot of money. And we estimate that across 8 filters, it saved them $300,000 to $400,000 in capital costs up front to eliminate all this conduit and wire through the use of our OSI bus network, but also through the use of the pneumatic vane actuators. And again, they were able to get an integral filter backwash optimization system that was proven built into their system. So here's some of the results. This is why people travel around the country to see this. We increased the flow of the plant from by 67% from 3 gallons per minute to 5 without any concrete or any substantial construction. We repurposed the existing filter tanks with new technology that allowed that capacity to happen. Their run times increased by 230% from 70 hours to an excess of 160 hours. That is exceptional performance, and that's at that higher flow rate. Everything's automatic now. We reduced their high wash durations, the length of time that created that butte in the earlier screen that you saw, from 13 minutes. Well, we left them at just under 5 minutes, and through their own tuning that the operations has worked on to perfect their backwashes, they've now reduced that to about 4.5 or 4 minutes at this point, which is really almost 10 minutes of reduction every backwash, which saves them about 62,000 gallons of water per backwash just in the high wash step. But it also reduces, when you do that, the need to continue to rewash the media when you're trying to place it back in the service. And that's a filter to waste, it's sometimes also called. And they were having to rewash or re-season their media after every backwash because of the overwashes for over an hour, over 60 minutes. And today, because they're not overwashing the media when they do a backwash, that number's down to 20 minutes. All of this water savings that took place by perfecting their backwashes increased their filter system efficiency from 92%, which is very low, to 98%, which is way above norm. Norm is about 97%. And the definition of this efficiency is filters backwashing time versus run time, and that's how they determine that number. But all this water added up to a savings from using 120,000 gallons of water to only needing 40,000 gallons of water to do a backwash at this point. And that actually accumulated over a year annually to, up to 100 million gallons of water. Now, 100 million gallons of water that this plant was wasting prior to the project every year, translated at 6.8 mgd, which was their average flow rate, to 14.75 days of production being sent to lagoons instead of their clear wells for no reason other than poor operational procedures and poor technology. Today, all this water is going to the clear well. Now, if you've got other water challenges, like you've got a very limited source of water, then it's important that for every drop of water that you get, that you don't waste any. And there are some cases in various parts of the country where the cost of procuring this water is extremely expensive. So if they're going to get it to their water plant when this happens, you know, then it's important that they use all this water to go to the clear wells and onto their consumers than it is to the lagoons or their wastewater treatment systems. On the other hand, if you've got a very challenged wastewater treatment system and you don't have much lagoon capacity, or God forbid, you're sending this wastewater to the wastewater treatment plant nearby, which is the most expensive way of treating it, then we want to cut down on that. But you could also have a situation where you can't get rid of the wastewater very quickly. And if that's the case, then that can prohibit you from being able to backwash your filters at all. And so you start to lose filter system efficiency from there. By reducing the wastewater, it will help operations keep their filters clean. It'll help them have consistent water quality across the entire system. So that's a lot of performance enhancements that came at this plant as a result of these technologies that were implemented there. So here's a picture of what it looks like today. And it's those are our consoles sitting in there. There's 8 filters. That is the water plant manager. The former water services director is right there as well in this particular picture. It's clean, it's neat, it's orderly. You'll also see over on the right side a picture of the filter pipe gallery. It certainly looks dramatically different than it did in the previous pictures. There are more shots of it here. You're looking at an effluent rate of flow controller there with the K-Torque pneumatic actuator on it and the Venturi tube. It sure looks a lot better than, I didn't do contrasting pictures, but I could have and showed you the difference, but we've really cleaned that up. But one thing you'll notice as you look down through that filter pipe gallery is there's not a lot of conduit wiring because there's no 480 volt power distribution system to the pneumatic actuators, and there's little to no conduit wire coming down from the consoles above to get to all of the instrumentation and to get to the actuators. All of that was eliminated by using the pneumatic actuators and by using the OSI bus network, an integral part of our system. It's important to note at the moment, since I get to talk about myself a little bit, this Filter Magic doesn't care if the client wants pneumatic actuators, electric actuators, or hydraulic actuators. But we try to bring the most innovative, cost-effective, long-term, reliable technologies to the client for them to make their decisions. So if they want electric, we got electric plants running anywhere at a number of locations throughout the country. They added air scour to this plant. You can see the air scour going down the back of the plant. And this happens many times when you're adding air scour to an existing plant. They have to find a unique way to get the air to the existing filter. So many times it runs over the top. In this case, they were able to run it on the back side of the filter building and run it in through the sides of the wall. You'll also see our backwash analyzer, which is what we insert into the water down at trough level so that we can understand what's going on. It's what generates the turbidity on top of the filter, either when it's settled water turbidity and coming in, or during the backwash, which is what you're observing here at the moment. You'll also see up in the upper right corner of that picture, the traditional ultrasonic level transmitter, which we use to control the level of the filter at that time. Okay, now we're going to move into innovative technologies and kind of what are these innovative technologies? And we're proud to show Powered by VT SCADA at this point. That's our latest generational step that we're very proud of and recently implemented and is going in on the second water plant, which we just recently received a confirmation that we're going to be doing for Fayette County, where the plant featured here is portrayed. We'll be doing their stuff here in the second half of this year, but we'll be going back to the first plant to upgrade them to this technology as well. It's the future. It's the next best thing we could come up with after zero waste to continue to be the best at what we do. So what you're seeing at this point is that we made a critical decision earlier this year to change from traditional OIT platforms and their limited capabilities to state-of-the-art industrial PCs powered by VT SCADA. That was a decision that was very critical to us. We don't make many because we sell a product and we try to keep it the same over and over again. But in this view, you can see the old screen and the new screen and what it's going to look like. It's much more user-friendly, it's much higher graphic, and much more functional. Another screen showing the filters and how they work and what we can do with those. Again, going to the industrial PCs on our consoles, going to the high performance VT SCADA software has allowed us to make every filter console in the filter gallery a master to all the others. It's the prime control system. It's got complete data acquisition within it. And for all filters, if they got 20 or whether they got 8, it doesn't matter. It's got all of them in it. And for some reason, if this one failed, it would move to number 2 or number 3 or number 4 and continue to operate all consoles as long as one is still operational without any loss of data and with complete functionality. We didn't do this for convenience for operations, so they didn't have to go down the hall. We did it for redundancy. And we were able to do it cost effectively at a high performance level because of VT SCADA. You're welcome, VT SCADA. Okay, this is what's really cool. You saw the previous screen of the old data that was acquired, but what you're looking at here through the power of VT SCADA in those industries is a complete backwash trend screen going right at the console. This data should be stored in everybody's plant SCADA system. Historical analysis should take place on it, modeling and future performance too. It should all come from utilizing this data. This is what we really wanted to get at the console. This is the latest generation of FilterMagic on view right at this moment. Okay, looking at the hardware just a tad. Well, there's our Aussie bus network sticking out of the bottom of the panel. What's of interest is that this console can handle up to 5 filters by itself. It would still only have one cable hanging out of the bottom of it. It would need 2 more cables, one for power and one for Ethernet to communicate. And those 3 little cables is all that needs to go into one of our consoles to handle an entire water plant, if they so choose to put it all in one industrial PC like you see there. Typically, we tend to have in a plant with 8 filters, we probably have 4 dual consoles at that point. But suffice it to say, that console right there, or one more of them, could have handled the entire Crosstown plant and eliminated all that conduit wire. If you'll notice the PLC in the open door of the console, it has no I/O cards. Our Aussie bus network eliminate all the I/O cards, all the hardware that can fail. It's not needed. Makes the troubleshooting, makes the panel kind of empty, makes the troubleshooting that much easier. So we eliminate a lot of conduit wire and a lot of traditional hardware that just isn't needed. And this technology, these technologies are highly reliable. They're highly proven. They're identical from one plant to the next. If you go from one FilterMagic plant to the next, you'll already know what to do when you're working with it. The only difference is if we add something new and make it better, and then it's backwards upgradable on anything we've ever done in the past. Okay, looking at that hall again, this is talking a little bit about that Aussie bus network. That is the backbone of our patent on the FilterMagic system. We control the Aussie bus networks in filter systems, water or wastewater, industrial, across the land. And that is the central component of what the Filter Magic patented technology is. It doesn't mean it's proprietary. It just means it's ours to use, and it shouldn't be used by anyone else. This technology eliminates 85% of all that conduit and wire. It eliminates the PLC-I/O cards. It's 2-wire. It's water immune. It's electrical immune. It's 24 volts. And even Chris can work on it. I'm confident of that. Okay. So that's one way to look at it. Here's another way to look at it. You're looking at the K-torque pneumatic actuator, the effluent rate of flow that we talked about. And then you can see a flex conduit coming up into the bottom of it. Inside that flex conduit are the only 2 electrical terminations on that actuator. And it happens to be a 16-gauge pair of wires for the Aussie bus network. That's it. It's the only electrical connections. No 3-phase power, no single-phase power. The airline coming into it is the power. And we don't need all the other wires for monitoring control because that's all eliminated by those 2 wires. Interestingly enough, those same 2 wires on an Aussie bus network provide the power to those solenoids that you see on the side of that actuator. So we don't need another pair of wires to power them up. The power and the I/O for monitoring and control is all contained within an Aussie bus network. Simple, simple, simple. There's the inside view of the actuator, and you know, Chris, can they see me in the corner of their screen? I don't know. Can they or not?
Yes, I can, Mark. Yep, you're an icon of top ranking. Yes.
Well, I'm going to show them the inside of one of these actuators then in that little screen just for a second. Most people, even if they have these actuators, have never seen it. These actuators are guaranteed for 2 million turns, which is roughly 2 Mayan calendars. And that's because if you do the math in backwash world, it's worth about 9,600 years of reliability. One moving part, a simple machine. I just thought I'd show that. The cost of ownership is extremely low. Again, we don't care if they use electric actuation or anything else. Clients can choose whatever they're comfortable with. But we like to show this to them and give them that option. And then if it goes in, it becomes a wonderful thing. All right, let's see. Got about 15 minutes left, 14, so I got to make sure I get through my stuff. Also, in the innovative technology department that's coupled into this is our backwash optimization system. And we like to ask, what's 1 minute worth? We do that all the time. It's politically much better than to say, we know you're wasting water. But when you got to go through the analysis of the thing, we want a client to sit there and think about how he performed his own backwashes so they can measure in his own mind what the value of what we're talking about is. And filter run times run from 30 to 150 hours, but in average, it's 70 hours. And that means that each filter is, on average, backwashed 125 pounds. And you can do the math. If you have 8, then you're going to have 1,000 backwashes in a year and 1,000 opportunities to save a lot of water through those backwashes. And many times it saves a bunch of water. So now we're going to have a test for everybody. And what you're looking at is our technology running here, and you can see it air scouring on the left. You can see a full mud boil. Chris, I don't know if you knew what a mud boil is, but there's a mud boil for you. But when you run that water backwards through that filter media after running 70 hours or 100 hours or 120 hours forward, it's got a lot of dirt that it's going to wash out. And that's the mud washing out of it over into the troughs. And you can start to see it clear on the right-hand side. If we go to the next set of screens, it's getting cleaner. It's getting much cleaner. And the last picture shows that it's been returned to service and it's starting to fill back up. So you can see the effect of how clean it is at that point. But we're going to have a little test here. Now, I'm just going to walk you through it because I can't see everybody's hands, which I normally ask them in the room, put your hands up on based on which one you think is the proper place to terminate a backwash. So if you look down at the bottom of the screen, 75% of all people participating in this survey would tell you that at that point, it's time to return that filter to service and stop backwashing it. Remember that butte that went by for 10 minutes. On the other hand, 25% of operations typically says that the picture on the left-hand side of the screen, which shows a little mud in it, is when they might do it. But what nobody says is that the right-hand picture on this screen is when they would do it. And that is the ideal moment to terminate your high wash during a backwash optimization. And it really blows their minds to see this, because when it's left to the mind, to a human to think through this and watch it with their own eyes, they're not comfortable with what they're looking at there. Automation is necessary to make them that comfortable so that they can perfect their backwashes. That's what zero to waste does. So that's our test. I couldn't get a show of hands, but we'll see how it works. All right, so here's another quick analysis just to help people looking for 8, 12 filters, very typical size, the number of backwashes and the amount of gallons that they might save. But please note on that last figure, each minute is worth 15 minutes of 15 million gallons of water saved annually. So if you save 10 minutes on that size plant, you could save 150 million gallons of water. That's a bunch of water. That's a bunch of water bottles. I'd rather you get this water from your faucet than I would from a water bottle. Okay, before I go there, I've kind of come through a lot of what we're going to do purely with Filter Magic. I'm going to come back to some Q&A, but we've got some new innovative technology I'm going to jump into a moment and feature, and I'm going to just talk about that for a second. Well, I guess I could talk about it for a few minutes, but here we go. So this is a new technology that we started rolling out late last year, and we're in full production at this point this year. And it's called the IQ system. It's powered by VT SCADA. That's what started our relationship with VT SCADA, was this very simple technology. Basically, zero to waste in itself needs a host. In itself, it's software and hardware that does something, but it needs a host. It was originally packaged and integral now to Filter Magic. That is that host. But we developed this low-cost filter backwash optimization system to be a low-cost host to take our water-saving technologies and bring them to every client that's out there in the industry. So if you don't need a capital project, or you've recently upgraded your filter control system, or just don't have the budget, but still want to save water, then our IQ system is just what you need. And that's the point behind it. What's every minute worth? Every drop counts. This is what we're focused on. This is what we've moved into. People call us today, they don't ask for Filter Magic in many cases. They call us zero to waste. They're fixated on zero to waste, even and above what Filter Magic means to them. Now we're giving them the IQ system. So these are some of the points behind the IQ system in itself. It was designed to be less than 10% of the cost of a capital project for a new filter control system. It moves it into a maintenance budget versus a capital budget at that level. It doesn't control the backwashes. What it does is it monitors, it analyzes, and provides the information to the client so that the client can use that information to fine tune whatever kind of control system that they have. They can take the knowledge, walk over to their consoles, adjust it, and over 2 or 3 backwashes through the use of the IQ system, they've calibrated their backwash for 85% water savings or more that they would get. So, you know, if you were going to get $1 million Filter Magic, which would be something similar that you saw in the earlier project, for $100,000, you can implement this at the same plant. And if you so choose that you go with the IQ system as a step towards ultimately upgrading the rest of your plant, then we'll absorb 100% of the IQ system into the future Filter Magic system that you would want from us at no additional cost to the project. That translates to a great down payment for that project. Ultimately, it's a low cost of ownership versus the value. We highly recommend that you give this serious consideration if you're not ready for a capital project. But we can come to work with all these technologies, all these innovative technologies in the filter building for the benefit of water clients, water plants with gravity filter systems, tertiary plants on wastewater plants. We're doing 125 MGD wastewater treatment plant right now. They got all these technologies going into it. We are putting them on 50 and 100 MGD water plants. But you know what? We've also got a 3-filter plant, multiple 3-filter plants that we're working with. They have tiny little flows, but it's just as important to them how they control their water systems. So, Chris, I think I've concluded my 40 minutes a couple minutes early. I hope that's not a problem. I could sing a song if necessary.
And not a problem at all. Although, no, maybe we'll save the song for the next virtual trade show.
Okay.
That way people have something to look forward to.
Virtual laugh show.
That's my personal philosophy towards these things. Thanks, Mark. That was great. You covered a lot of ground there, and I was really interested. You've got a couple of interesting sort of paradigm shifts here. You know, a real different way of looking at things. So, like for example, replacing sort of a single-use, single location OIT, which is a panel that's built to do one thing in one place, and replacing that with a SCADA system, and so that every panel would actually be a different node in your redundant SCADA system, and all the benefits you get from that. I guess my question to you is, and you've also got another paradigm shift with a hosted solution with your IQ system, which is really great. So my question to you is, when you are proposing a technology like this that maybe is different than what most people have been using for a long time, do you find there's a lot of pushback, or do you find that people are open to exciting ideas like that?
Well, that's a fascinating question and very appropriate. The answer to that is that, as far as I'm concerned, we have the best technologies for filter systems that exist on Earth. And every plant should just want to do it as soon as they can afford it. But that's not the case. That's not the case. And so we've found that indifference, a tendency to want to use older technologies and not trust new technologies, politics, key stakeholders involved in it that it conflicts with their part of the project. All of these things come together to make it very challenging. And this is a process, not an integrated solution as a plant integrator might do. So it's found in a different part of the project, and it includes elements of various sections all under that process section where other processes come to the project. So the bottom line to the answer to that question is that ultimately the client almost always, although not every time, but almost always makes the decision through cultivation with that client that, no, this is what I'm going to do. And Mr. Consultant, this is what we want you to do for us. And they either do it themselves, and in some cases, they actually go on and implement it themselves without the benefit of a big design and a general contractor. And in other times, they direct the consultant to embed it in their design, and they either pre-negotiate it or, you know, it goes out for a competitive bid that way. But it challenges the municipal mindset is what it really does.
Right.
And it can be done this way. As you saw earlier, it can be done this way and save a lot of money and provide a ton of benefit. So we have to continue to get the good word out. And this venue today is helping us do that, Chris. I want to thank you for that.
Oh, you're very welcome. So I also wanted to say, if anybody has any other questions, we haven't had any questions in a little while now. Just type them into the Q&A interface at the bottom of the screen, or in the chat one too. I can see them both. In the meanwhile, while you're typing that in, I just wanted to follow up with a question about hosted systems. Now, I was trying to follow along because this is the first I've heard about the IQ system. I had heard about the Filter Magic at the virtual trade show. For this hosted system, are people able to migrate from this so basically it lives in a cloud and people are able to interact with it, I assume, using a thin client? Is that right?
Yes, it's actually your lowest cost technology will fit into what we're doing. But
right.
Actually, if you were to hold your cell phone up or a tablet, that's where it's going to live.
Right.
But there's a certain amount of hardware installed at the plant on each filter so that we can get the data we want, in addition to other data that we would require from the existing system. That data is combined through the use of some very unique technology, and then wirelessly transmitted out to interface with any client's cell phone, tablet, smart device, even their computer, if that's what they can take their cell phone and walk up to the side of a console, and they'll say through the app that's in there that you know, this is what I'm going to do, this is why I'm going to do it, this is what I desire, and then they're going to run a backwash while this is watching what they're doing, and it's going to come back and say, "You schmuck." Well, maybe.
Do you have an alert that actually says "you schmuck"?
Yeah, we do. We just don't plan to use it. But what it'll say is,
well, like you said, tact is an important part of what you do, isn't it?
But what it said was, basically what it said to him was, Chris, was that it said, you desired to do these things, and this is what you actually did, and you're not even close.
Right.
So why don't you make some changes the way we recommend it and run another one? And they got to wait 3 days to run another one because it takes that long for filters. But over about 2 weeks and 3 or 4 backwashes, they'll get within that 85% number at that point.
Right.
And periodically, they're going to have to check it. The full filter magic doesn't care what the temperature of the water is, which is a big factor in backwashing. But because this is passive, not active, then when they move from winter to summer conditions, they may have to retest their systems to fine tune it. And again, this data is now being collected through our systems, our technologies, and is available to their plant SCADA systems passively, even if they're not directly doing it themselves.
Right.
So it's a very interesting passive approach to getting things done, but much more user-friendly to a client when they don't have a capital project in place for the next 5, 6, or 7 years.
Yeah, that's a big deal to not have to spend all that money up front to host your entire internal network, SCADA servers, manage your own redundancy. All of that just sort of comes with a turnkey solution. And like you said, it becomes an expense as opposed to a cost, which is, again, a paradigm shift, a different way to think.
We're running out of ways to find improvements in the filter world.
Right.
The big ones are all being addressed. There's not many new ones left, but we're continuing to do our research and development, and we may focus on the lights next, so that when you step in, they turn on, and when you step out, they turn off.
Right.
But I don't know what else we're going to be doing. But right now, this is there's a world of this stuff is going international. Our patents are going international. We're looking at neighboring countries in Europe to spread them out. And again, we're getting a lot of interest in what we're doing.
That's great. Well, it looks like there's no questions, which means that you did a great job of explaining all of that. You covered a lot of ground. So again, thanks for joining us, Mark. And I look forward to seeing you at another virtual trade show down the road.
Well, you know, Chris, it could also mean that nobody actually cares about what I was talking about. Maybe that's why.
Well, no, I'm looking at the numbers of people, and it fluctuates as people come in and out, and you've held your numbers through the whole thing. So I think that speaks to a lot of value in that content. So thanks, Mark.
Well, I want to thank everybody that participated and listened to what I had to say today. And if you need to get a hold of me after that, my information is at the bottom of the screen. You can find us in LinkedIn. Please reach out to us so that we can answer more questions or evaluate your existing systems. Chris, many thanks again to the VT SCADA team. These are wonderful venues, and I hope to be back again. Thank you.
Great. Our pleasure. Thanks, Mark.
Adios.
Coming up next at the top of the hour, in our third hour, Dave Epsey from Jacobs is in the cybersecurity and general automation. Over in the oil and gas stream, we will have Quantum, Mark Reski and Tyler Davis. And coming up in our stream at the top of the hour is going to be quite a party. We've got Mark Edelman and Ramnath Sikar, and they are going to do a presentation with 2 other people. So it's going to be a real party call. So stay tuned for that. So in the meanwhile, you've been sitting here staring at the screen and focusing your eyes. So I encourage you to stand up, stretch, walk around the room a bit, get a glass of water. And I think I will do the same. So talk to you at the top of the hour. Hi, everybody, and welcome back for our third hour. First of all, I'm just going to introduce Mark Edelman. He's the Director of Business Development. Hi, Mark. How are you today?
Great. How are you?
I'm great. I'm going to very quickly hand this over to you so I don't use up much of your time, and I'll let you do the introductions of everybody else. Does that sound good?
That would be great. Okay. Well, first of all, Chris, I'd like to thank you for allowing us to participate in this event today. What I want to start with is introducing the other members of our panel. Ram Sikar, who is the project manager for EN Automation for this effort. Mike McGill, who is superintendent of operations and maintenance for the wastewater for the city of Pasadena, Texas. Elias Ruiz, who's the IT SCADA manager for Infomark. So before we get started, I'd like to tell you just a little bit about EN Automation, who we are and what we do. We are one of the largest systems integrators in the nation. We have over 150 automation professionals in offices across the country. The primary industries that we serve include pipelines, oil and gas, electric and gas utilities, water and wastewater, and food and beverage. We support just about every major HMI, PLC, and SCADA platform that's available today. EN Automation is a division of EN Engineering, which is a full-service engineering and consulting firm that serves the energy industry with over 1,800 employees in more than 35 offices across the nation, actually across North America. With that, I would like to turn it over to Ram, and he's going to take us through the project.
EN Automation, we are in the final stages of completion of SCADA platform for City of Pasadena wastewater system, and also some of the freshwater facilities that are integrated into the system as well. So we used VT SCADA, and this has been an elaborate project which involved integration of several facilities, wastewater treatment plants, lift stations, freshwater sites, into a single centralized VT SCADA system, and the process was to replace an existing legacy SCADA system with the newer features and the more advanced VT SCADA system. And we also, I guess, took advantage of a lot of the IT features that City of Pasadena provided to us to be able to implement some virtual commissioning aspect as part of this project. I would like to start by going over some of the features and then the SCADA system itself before commenting finally on how the virtual commissioning methodology was followed. The team here for this particular case is City of Pasadena, who is an owner-operator. They own the water treatment plants, the freshwater sites, and also the lift stations. The group from City of Pasadena, their operators operate all the lift station sites, and there is a different group that operates the freshwater sites, which is primarily storage tanks and water towers. Inframark operate the wastewater treatment plants, and there is two massive wastewater treatment plants that City of Pasadena own, that's operated by Inframark. EN Automation, we are the system integrator, and we, as part of system integration, we've provided software support and hardware by way of control panels, radio, Ethernet radio equipment, and some design aspects related to that, which is some of the design features and panel features that we have provided to them. The existing system, which is the City of Pasadena Water Department, it serves, as you can see here, about 36,000 customers. And the facilities that are kind of the ones which are of interest and the ones we are monitoring and integrating into SCADA is two wastewater treatment plants with a total capacity of 18 million gallon every day. That's the throughput of these plants. And the lift stations, there's about 50 odd lift station sites, 9 to 10 ground storage tanks, 6 water towers, and then well sites also. These are spread all over the City of Pasadena, which is several square miles of area, and they are primarily networked or integrated using Ethernet radios and radio equipment. So now talking about the SCADA system, there was a legacy SCADA system that was housed at the Wince Bayou or North Main wastewater treatment plant. And that's also the house for the new SCADA system, which is implemented using VT SCADA. Like I had mentioned, Ethernet radios is primarily the communication mechanism from the central site, which is the Vince Bayou treatment plant, to several other sites that are feeding information back to the central system. The radio access points are hosted on water towers, obviously the highest point that you can find. And all the remote sites, they interact with these access points in order to establish the information pipeline. The facilities, both wastewater treatment plants and the remote sites, they have a variable set of PLCs. It's Siemens platform, both S7-200s, S7-300s, and S7-1200s. We've got Allen Bradley, the Logix platform, which is compact Logix, and they also have older non-Logix based micro-Logix PLCs in some sites. And then they've got some Schneider Electric SCADA pack PLCs at some of these sites. Now here's where one of the biggest assets of VT SCADA for this application was of great advantage to us, is that pretty much every type of PLC was capable of being communicated to with the inbuilt driver package of VT SCADA. And that was a huge plus. That way we didn't have to maintain multiple configurations. And for any SCADA integrator, we typically, yeah, that's something we appreciate. And the legacy system, it relied on a third-party driver package in order to communicate with these PLCs. And normally with third-party drivers, you have to have one driver suite for each platform or each model of PLCs. So you would have to have a Siemens driver suite, an Allen Bradley, a SCADA pack. But VT SCADA's inbuilt drivers made sure that we didn't have to rely on any other driver software for communication. Because of the Ethernet radio equipment and a lot of the legacy hardware, there is currently some issues with getting communication to some of the remote sites, and that is something that City of Pasadena, Inframark, and us are working towards. Making things better and looking at alternative options and whatnot to establish communication. All right, so VT SCADA, the version of VT SCADA that we are currently using is 11.3, and this is a redundant, fully redundant VT SCADA application with a primary server that's a physical machine, and that's located at Vince Bayou wastewater treatment plant. And it has a redundant backup that's at an offsite location. And the integration between, or the synchronization between primary and secondary is as seamless as we've seen. And yeah, we really appreciate that. We also have two permanent WIC clients, one at each wastewater treatment plant. And we already touched the aspect of the built-in drivers and what a big advantage it's proven with several different PLC platforms that we interface with. One of the bigger pluses, and this is over the legacy platform, is that we've got unlimited internet clients or web clients, and that allows their group to not face any sort of capacity restrictions, or call another operator and say, hey, you need to log off so I can log in. That problem or that issue is no longer there And that's definitely seen as another huge asset with the way the VT SCADA system is set up. Not to mention the scalable graphics. Again, legacy platform did not support graphic scaling. Your monitor resolution had to be fixed and match what the graphics were developed for. But yeah, VT SCADA has definitely improved that and made the graphics scalable so that they can view it from any device, a laptop, a computer screen, a portable pad like a iPad or something, and then even maybe a smartphone. Not that it's the best of interfaces and you don't want to strain yourself looking it through it, but the capability is there, and the graphics, they scale pretty neat, and we don't have issues with skewed graphics or anything of that nature. We've set up audit log where operator actions can be traced, like acknowledging alarms, modifying set points. These are pretty well tracked, and again, features that definitely help out. And then lastly, which is probably one of our biggest, I guess, contributions through VT SCADA to the city and Inframark is that, as we discussed, this is a rather big application with several groups or several domains working in the same application. Like you've got freshwater sites, we've got wastewater treatment plants, we've got lift stations, and the personnel or operators are different for these different groups. That's where the VT SCADA realm-based area filtering allowed us to set the application up and set up realms that when a wastewater treatment plant operator logged in, all they saw was information related to wastewater treatment plants and nothing else. And this included, graphical interfaces, alarming historical data points that are available for trend, even audible alarms where, if an alarm in the water plant goes off, this client with that login will have the audible based on that. So the realm-based area filtering is definitely something that was a massive feature that helped out in this application. So as part of our deliverable or as part of EN Automation's involvement, we provided systems integration and software development, which included PLCs, HMIs, and SCADA system. It included control panel design and fabrication, which we provided from our panel shop here in Houston. We also designed and installed Ethernet radio communication infrastructure within the two wastewater treatment plants, almost like an intranet or within the plant network. And then we provided factory acceptance testing services for panels and software. And then the implementation, which is testing and commissioning, involved site presence and also virtual commissioning. So that's the scope of work that we provided as part of this project. And as we are trying to approach the final stages, we continue to do so. So as part of today's demonstration, we wanted to show some of the graphic features that are available or that have been provided to City of Pasadena and Inframark as part of this VT SCADA application. I wanted to start by going over some of the information from the lift station sites. And for the benefit of everyone here, a lift station is primarily a station or a site that pumps the wastewater from the location into the wastewater treatment plants. So like I was mentioning with the realm-based area filtering, as you can see towards the top right corner, we have a group created or a realm created called lift station realm. And then when the lift station operator enters their credentials, the initial view is this, where every aspect of the system is available on a map-based overview. As you can see, Golden Acres up top is one of the wastewater treatment plants. We've got ground storage tanks, lift stations, rodeo grounds is one of the miscellaneous sites. We've got the Vince Bayou plant and water towers. But once the operator related to the lift station realm logs on, he only sees what he's supposed to see, which is lift stations and rodeo grounds. And when they click on lift stations, they have a view of several lift stations that are spread all across the city of Pasadena system. Like I had mentioned before, some of the legacy hardware on the communication side meant that there are some communication issues reaching out to a good number of the sites, and it's sporadic. At the time I captured the screenshot, this was the status, but normally it changes. But like I said, it's one of those things where we are trying to, as a group, try to solve the communication issue and look at alternative communication mechanisms from the remote sites to the central site. And this, for example, is one of the lift stations at North Main. And a typical lift station set of equipment is the pumps that empty out the lift pit or the well, and they send that wastewater to the water treatment plant. It's got some simpler control strategies, which is stage based on set points. And a lot of the VT SCADA graphic elements that are native is what we ended up using. And it was pretty good. The customer is happy, and they have been using this to monitor their lift station sites. And it's all part of our tag templates that we built into VT SCADA. And that's something that we've been able to set up more like an object-oriented programming strategy. Moving on to, again, the benefit of the realm-based filtering is that the lift station operator only sees alarms that are active and or that are present related to the lift station sites, and he doesn't have to look at any of the other alarms that are part of the same system. It's just that they don't belong to his realm. Similar feature, the realm filtering filters out all the historical data to only show the subset of historical data that is of interest to the lift station operator. The next section is the Vince Bayou wastewater treatment plant, which is probably the most involved when it comes to an operations and capacity standpoint. And once again, similar to the lift stations, WTP realm, which is Vince Bayou wastewater treatment plant. Once the operator under that realm accesses it, he looks at this screen, which is just Vince Bayou wastewater treatment plant. Once he steps into it, this is an overview of the facility and on the equipment it supports. This is a lot of the graphical features here were custom graphics that EN Automation, our group, developed as part of this project. And we have been through the project and previous projects to get a good library that we have been able to use on projects such as these, and have gotten very good response from the end user and the operators. Also, just to demonstrate, these are some custom graphic faceplates. What you're seeing here is a faceplate for a transmitter that we developed in VT SCADA and maintain as a library locally. And then this is, for instance, the faceplate that we have designed for controlling the VFD with VT SCADA's native elements and custom graphics. And this is, for instance, the PID control faceplate for the aerator motors at the wastewater treatment plant. This one's a motor control faceplate, which is just for controlling standard on-off motor starters. UV system, the Winsbayou wastewater treatment plant has a UV system that was a standalone island provided by a different vendor, and we integrated that information. We don't do a lot of control. That's a standalone system, but we definitely monitor a lot of the information from the UV system, and those screens there represent the data from the UV system. And then moving on to Golden Acres wastewater treatment plant. This is a plant where the communication is definitely not good at the moment. We're trying to fix it. The wastewater treatment realm, again, if you look at it, it says GA WWTP realm, and it's for the Golden Acres wastewater treatment plant. Operator logs in, who is a plant operator for Golden Acres. That's all he sees. And then he steps into the plant overview, which again, Golden Acres comprises of Siemens, Legacy, and new Allen Bradley PLCs, which are all sending data back. The influence system, which is here on the left side, it's controlled by a SCADA pack PLC, and again, as part of system integration, we've had to get all that information coming into VT SCADA. Moving on to the freshwater sites, which is ground storage tanks and water towers. Again, we've created a freshwater realm, which applies to the freshwater operators. When they log on, they can see all the freshwater sites. And this obviously has got all the towers and the other sites there. This would be just the towers alone, and the previous slide here shows the towers and the ground storage tanks. And then once they, so that was a breakdown of just the towers, and this is a breakdown of just the storage tanks. And then this would be a typical screen for a ground storage tank site. As you can see from the level trend, we are polling the site at a faster basis right now. And you can see the gaps that would be indicative of communication loss. This is water towers, a typical setup for a water tower. And again, as far as the water tower sites and the ground storage tank sites go, we typically do mainly monitoring, and there is not a lot of control that is presently there. So, having given a brief overview of the actual SCADA system from an implementation standpoint, just wanted to briefly run through the benefits and whatnot. And reliability when compared to the legacy platform is definitely there, and with the redundancy aspect of it, the uptime is been close to, if not 100%. The unlimited web clients and the scalable graphics means that the operators are a lot more flexible with being able to access the application. Realm-based area filtering, can't talk enough about that feature. I think it was a lifesaver on this project. And then we also have notification pipelines. We currently do not use the text and call notifications, but we do use the email alarm notifications, which is prioritized based on alarm category and re-alarm times and several different settings related to that. We have, as part of this project, been able to not only remotely implement the features, but when it comes to commissioning, we've had our SCADA programmer be remotely accessible and the PLC programmer on site, and the typical site commissioning was handled 50% of it via virtual commissioning, and then the 50% of it with field support where the PLC guy was on site. Now, in a world where the communication is improved and VTs and the city of Pasadena system networking is made better, we do imagine a lot of troubleshooting / commissioning activities could go lean towards the virtual commissioning aspect of it. As far as training the operators and organizing training sessions, the virtual presence has made it a lot more easier to be on a call such as the one we are on right now and be able to train the operators on the live system. Yeah, that's definitely a huge time and cost saving as part of the setup that we currently have with the city of Pasadena system. Having said that, I kind of roll into the ending of my part of the presentation here. And again, we wanted to, I guess, give a good demonstration of the city of Pasadena system and Inframark, and also Ian's capabilities with overall system integration, panels, and fabrication and use of VT SCADA. And yeah, this application was an ideal scenario for a platform such as VT SCADA, and we definitely have reaped benefits of several of VT SCADA's features. So having said that, Chris, I would like to, I guess, pass it back to you.
And I've got a few questions, actually, that I might throw your way. So one of the questions, actually, somebody stole my question, which is your VT SCADA application is running 11.3, which is, of course, a great version. But do you have any plans to migrate it to version 12?
Yes, we've discussed that with Inframark and City of Pasadena. Yes, the plan is to migrate it to version 12, and we made sure our support contracts and everything is in place. The plan is in the pipeline, but we haven't identified a date yet. But yeah, we do want to leverage some of the newer and additional features that version 12 brings us.
And that's great. Elias, I'm sorry to cut you off there. Do you have anything that you wanted to add at this point?
No, other than to say that Inframark as a whole is kind of taking a holistic approach to integration of SCADA systems, and obviously modernizing many of the clients that we currently hold contracts for. Pasadena was kind of the first one that we kicked off with as a company as a whole, where we actually started requesting specific implementations be put in and certain things be upgraded to make it better for the client. As Ram stated earlier, there was a lot of legacy systems that were out there, or a lot of legacy parts that have just gone by the wayside just because they've reached end of life. There is no substitution or replacement for them, which in this industry, when you have something fail, it can be a compliance issue or a health and safety issue. We wanted to stay above and stay forward moving with technology as it improves. And as Ram stated, the plan is to eventually upgrade to the newest version. And hopefully we've developed an end of life cycle for all of the hardware and software systems so that we are staying on top of those changes as they come about, and the city can then turn around and budget and plan for those systems overhauls within 10 to 12 years.
Right. Yes, that's certainly the advantage of VT SCADA. One of the reasons why we build in so many features standard is so that over time they'll all work together in lockstep, so that we don't have some third-party thing get depreciated over time, and then you've got a compatibility issue. And so the end result is that you can just continue to upgrade VT SCADA indefinitely.
Right. I was going to say that one of the other things that we did also take into account is that we found in a lot of our other projects, not just Pasadena, but a lot of other projects, we found that support agreements had lapsed. Right. And technical assistance from the integration company or the software company as a whole had lapsed. And So therefore, you weren't really doing anybody any favors, because when you had problems or patches were pushed out or updates that were made, you had nowhere or no one to contact.
Right.
So we ensured that the support agreement was in place, and that hopefully the city of Pasadena will maintain that, as well as Infomark. We're only a steward of what we're given.
Right. That's great. So another question that we have here, which is, do you provide a secondary communication link between VT-SCADA servers and each station, especially to the water wastewater treatment plants?
Do we provide a secondary communication link?
Yeah, as part of the SCADA system, or as, yeah, like I guess, for example, if you were to have Ethernet and radio, I guess.
Currently, because of the challenge we have with that is obviously, as Ram alluded to earlier, was that the distribution of the stations was so vast across the city that a lot of times it's just not practical to run a complete fiber connection to, or to run a Ethernet cord. So we're only limited by the radio link.
Right.
That was discussed with the city, and I believe, Ram, correct me if I'm wrong, but they are currently going through and upgrading their radio system, correct?
Yeah, the city of Pasadena is going through a whole infrastructure modification or upgrade to go through and replace a lot of the legacy equipment with newer radio equipment. But still, it's still going to be Ethernet radios as the primary setup. There is also talk about having cell modems as a backup or a secondary. So to kind of follow up on the question from the user, the plan is to provide cellular backup to Ethernet radios, but obviously the cost of cellular radios on a number of sites, like if you add up the total number of sites coming back here, it's reaching 100, and they will grow in future. Right. So they have to make, it's something that city of Pasadena are evaluating from a priority standpoint on saying, if there is a site that's critical, maybe we will look at that as part of a site which will need cellular backup in case the radio network is not communicating.
Right. So the VT-SCADA multiplexer driver, the MUX driver, makes it pretty easy to do that. Whether maybe like some places might have a spare copper wire telephone line that wasn't being used, or like you said, in this case, you've got a cheap form of communication like radio, and then an expensive form of backup like cellular, so that the MUX driver could default to one but fail over to the other in an emergency situation. So I don't see any other questions, and unfortunately, we were supposed to be joined by Mike, the superintendent at the city. Unfortunately, due to some technical issues, he wasn't able to join us. So I apologize for that. Did you folks have anything else you wanted to end with before we go?
Yeah, I just wanted to reiterate that for this particular application, I think VT-SCADA definitely fit the bill. It was the features and yeah, like I mentioned previously too, the realm-based filtering and whatnot, as advertised, were absolutely critical in accomplishing the goal that City of Pasadena and Infomark set out for the project. So yeah, we are happy with the way things have been working with VT-SCADA, and we hope that we can enlarge and expand the system to make it. Maybe on the next presentation, we'll have more slides about this.
Yeah, that would be great. I look forward to that. And I was also excited to see all of the progress you've made. I guess you already were doing virtual commissioning before all of this began. So it's exciting to see those kinds of standards and practice evolve for an evolving time.
I wanted to say we've been doing virtual commissioning since 2015, actually. For a variety of different industries. So
you're ahead of the curve.
I wanted to thank you again for the opportunity for us to present this. If anyone has any additional questions or any follow-up, please, our contact information's here. Contact either me or Ram. We'd be happy to help you or answer any additional questions that you may have. So.
Excellent. Thank you all very much. I appreciate you coming on the show today.
All right. Thank you.
Thank you.
My pleasure. So that was EN Automation, Mark Edelman, Ram Sikar, and Elias Ruiz. Thank you for joining us. Thank you for those of you who sat for 3 hours listening to us. Thank you so much. We appreciate it. And also, I wanted to make you aware of the next upcoming automation virtual trade show. As you can see, that's coming up on May 14th. We're taking our dog and pony show on the road. We're going to be virtually in Chicago on that trip, just like we're technically virtually anywhere at any given time. You can virtually be in that place. We, of course, have a long history with Chicago because that's where WEFTech takes place every other year. For those of you in the water wastewater industry, you're well acquainted with that. You've probably been to many of these buildings several times. So we're going to do that on the 14th. Follow the link on our website if you want to register for that. As always, there will be prizes, there will be expert speakers, and there'll be some interesting chances to learn about automation. So thank you very much. I'm going to call her quits now. Have a good day and stay safe, everyone.